To explain photoelectric effect, Einstein assumed that light behaves as a packet of energy called as photon. Now, the photon which comes from the source, it is doing two work here. So, first work is ejecting the electron out of the surface, and the second work is that it gives kinetic energy to the electron, photoelectron, what we have. So, a packet of energy is doing two types of work, correct? So, what we have is that as the light hits the metal, it should eject the electron. That is nothing but the minimum energy required for the electron to get out of the orbit. That was nothing but work function. So, we have the work function, photon is doing that also, and once the electron gets ejected out of the surface, that should move towards the collector. So, for that also it needs energy. So, photon is doing both the work. That means the energy of the photon, which is equal to h into nu, should be equal to the work function plus the kinetic energy, right? So, we have h nu is equal to omega plus half mv square max, the maximum kinetic energy. Now, omega is nothing but the work function, right? So, what we have is omega is again the energy which is given, the minimum energy, right? So, we have h nu is equal to h nu naught plus half mv square max. Now, here h anyway is Planck's constant, nu is the frequency of the given photon, the incoming photon, alright. Nu naught is the frequency in which the minimum frequency that should be there for the photon. Minimum frequency was what? Threshold frequency, right? So, nu is the frequency, nu naught is the threshold frequency, half mv square max, the kinetic energy. So, this could explain how the threshold frequency is also applicable for every metal, because previously when they found out the energy of the photon, it was E is equal to h nu. That could not explain why threshold frequency exists, but this Einstein's equation, which is h nu is equal to h nu naught plus half mv square max, explains how the threshold frequency for every metal exists and how it changes for each and every metal. How we get it is, see, we'll get half mv square max is equal to h nu minus h nu naught, right? Or we can say half mv square max is equal to h into nu minus nu naught. Now, if my frequency is above the threshold frequency, this is positive, correct? If it is equal to threshold frequency, it's 0. If it's less than threshold frequency, it's negative. Now, can the kinetic energy ever be negative? Not possible. It could be equal to 0, or it could be any value greater than 0. So, this explains why the frequency of the incident photon should be greater than the threshold frequency. Understood? Now, when we write the graph, see, this is how it looks like. See, the negative intercept what we have, negative intercept. So, this part is a negative kinetic energy which doesn't exist. So, Einstein's equation, which is h nu is equal to h nu naught plus half mv square max, explains very intricate details of photoelectric effect, which is one, very important, the threshold frequency or existence of threshold frequency. Second, how kinetic energy changes. Third, why that negative intercept will come. Okay, so these are the three important points which we can take from Einstein's photoelectric equation.